Introducing DCM. Fortify's digital composite manufacturing platform enables material properties that can't be achieved with 3D printed photopolymers on their own. Fortify achieves these properties by suspending and aligning functional additives in a resin matrix during printing. DCM integrates the additives with hardware, software, and materials. Fortify produces the most functional, high-resolution 3D printed parts available. Functional 3D printed parts aren't just manufactured, they're fortified.
Good day, everyone, and welcome. I'm Brennan Lafferty, publisher of Plastics News. This is Ask the Expert, our new live stream series. Now, with Ask the Expert, this is your chance to engage with professionals, to address the current business environment, to discuss best practices, and of course, to ask some questions. This week's topic is improving operations, and we have 6 live streams scheduled this week on various operations issues. Today's topic, 3D printed tooling. Our expert today is from Fortify. Representing Fortify is Vice President of Business Development, Ben Arnold. Now, Ben has worked in 3D printing for more than 15 years in both polymers and metals. He's worked on dozens of injection mold tooling projects, and he is the leading Fortify go-to-market strategist with the new technology he will be sharing today. Now, Ben will answer your questions after his presentations. To submit a question, email pnevents@crane.com, or if you're watching the live stream on a social media platform, send your questions through those platforms. With that, I'll turn things over to Ben Arnold of Fortify. Take it away, Ben.
Thank you, Brennan, and thanks everybody for tuning in today. Hopefully we'll shed some new light on things and get through these presentation slides so we can get the important part, which is Q&A. So with that, we will roll into the presentation. As Brennan said, I've been seen a lot of different things tried over the years with applying 3D printing into the injection mold tool arena. The slides, are the slides live? Oh, okay, I can't see the slides. Okay, well, we'll just go through them then. We'll be on slide 2 now, which would be the prototype molding conundrum. And because the challenge, of course, in this conundrum is that as early as possible in the design process, everyone wants to have actual parts, prototype parts they can hold in their hands. The promise of 3D printing has long been used, but the problem is that many times you need to have actual engineering materials, right? Prototypes in another material are good for look and feel, but when you need to do functional testing, having your actual engineering materials, molded parts is critical. But traditional tooling is a burden at this stage. The schedules, the budgets, many times don't allow for traditional tooling. And 3D printing tooling has long been presented as a way to bridge that gap and solve that problem. So Fortify, we can't claim to have invented the idea for 3D printed tooling. We'll talk in a few minutes about some of the things we're doing differently to increase performance and raise the bar. But on the next slide, I think we'll just spend a few more minutes on what is the case, why consider 3D printed tooling as an operational factor. That's the focus of the series this week. But the point of being able to have parts, molded parts, 3 to 6 days, 1 week turnaround to have actual molded parts in your hands instead of maybe a 3 to 6 week turnaround time for a few $100s instead of several $1,000s. This is a pretty compelling case if you can deliver on it, right? From an operational standpoint, we have advantages like keeping CNC machines. If you're doing your own tooling in-house, you're able to keep CNC machines on higher value jobs, production tooling and the like. You're able to avoid rework on product launches and several more reasons. On the next slide, we have a series of what we would call our top 10 reasons to use 3D printed tooling. I don't plan to go through each of these in detail, but these are feedback we get as we work with customers. We don't make these up, but we're listening to customers, listening to the folks that we're working with, using our solution in the field around saving money, saving time, better customer satisfaction, faster product launches, and again, best use of resources. These are our website. This will be a theme I'll repeat often through the session here. But if you go to 3dfortify.com, you'll find a deep dive on all these top 10 reasons, as well as that we will be sharing as we go through the more slides here. So there's just really a series of very compelling reasons to use 3D printing. Again, it's in my 15 to almost 16 years now in the 3D printing industry. This has been a constant theme of how can we apply the additive technologies to improve not just parts in hand, but to support the traditional mold processes. So what is it that Fortify is doing different? This is where we'll spend a few minutes and a few slides on what Fortify is doing differently. You can't approach the problem with the same tools and expect different results. So Fortify has definitely developed some new tools and a new platform for 3D printing that involves the complete, what we would call a full stack: hardware, software, and materials. And the business model of Fortify is we sell 3D printers. That is our business model. We provide a number of services in support of our primary business, which is the machines. But in order to achieve a next level of performance, we've taken the full stack, if you will, in-house. We have partners that we work with on the material side, global partners like Henkel Loctite and others that help tremendously with their deep resources. But ultimately, it's Fortify's responsibility to make this all work together. And on the next slide, we'll talk about a few of the key technical breakthroughs that we have. The premise of Fortify is one that will be very familiar to injection molders that are on the call today. The use of additives, fiber reinforcement. This is something that's been done in the injection mold tool arena for quite some time. Glass-filled nylons, these are all familiar materials to you all. And we're just taking that technology and porting it into the 3D printed world. In order to do that, we have to have first a mixing module, continuous kinetic mixing, CKM. And that's what allows us to keep fiber in suspension, keep it in solution. And then we use a magnetic alignment module called flux print to actually align particles. If that's all the time we're going to spend on it here, but if we had the short introductory video that you saw, that full process video is available on our website, and it goes into great detail of exactly how these two modules work and how they work together to improve the material properties. The actual results of material properties on the next slide. We'll talk about the one embodiment of our technology called digital tooling. Digital tooling material has a ceramic fiber reinforcement in a high performance photopolymer. And again, you can get the full spec sheet on this material to download from our website. But the key metrics here I've circled, which are tensile strength, stiffness, Young's modulus, which is stiffness, and heat deflection temperature. These are the key attributes that make for higher performance in the molding application. And these are 2 to 3 times higher than competitive materials on the market. On the next slide, we'll show an actual head-to-head comparison of our tool. This is our Fortify digital tooling resin, ceramic reinforced tooling. This was a test on very specific life test on these extruded features. So you can see that's our tool after 100 shots. A competitive tool failed on the very first shot under the exact same molding conditions with ABS plastic. And I'll just say this, that I know this product, a competitive 3D printed tool. It's not that it doesn't work. It works well. It just clearly doesn't measure up. We're raising the bar to basically extend and expand the application space for this technology. And we have data that really does support. We're not just making claims, but we've done the testing to show that we do provide these advantages. I'd like to share a couple of case studies now, as well as we move toward the Q&A session, that says it's not just Fortify that says we're getting these results. This was a case study we worked on with an automotive supplier in the Midwest. They had attempted this part. It's a glass-filled nylon part, 35% glass-filled nylon part. Had attempted that with other 3D printed tooling with no success at all. Our tool got 50 shots of nylon 6 and then another 50 shots of the 35% glass-filled nylon 6. The target here was 25 shots, so we felt pretty good about our results there. And this was a tool that we produced in a week's time for $500, where the current technology, and again, even at the prototype stage, they're waiting every time they wanted to test a new design. So that's a real use case. The next use case highlights a different sort of an aspect of the tooling, which is the ability to print textures, prints, all things that might require EDM with a conventional tooling approach can be 3D printed directly into a tool, no extra cost associated with these fine features and complex detail. Again, this was a very small part, literally $150 total cost in one day to get that tool ready on a 3D printer, where $10,000 plus and 2 to 4 week turnaround time from other suppliers. So it's compelling. It's a compelling story. The third case we'll do is it speaks to another aspect of the tooling we talked about, which is the stiffness and heat deflection temperature. And this goes to repeatability, not just how long does the tool last, but do the results, parts coming off the tool, they have the same consistency and repeatability that folks have come to expect from production tooling. And in this case, on a small medical part, we ran our tool on 2 separate days. This was last summer, and compared those to inventory parts and found that of course, the inventory was in spec, but that the 3D printed molds produced parts that were also within tolerance, fairly tight tolerance specification. So this is a quick run through here. Please feel free to contact Fortify or me afterwards for a deeper dive on any of those case studies. This typical project timeline sort of says, how do we get to this 1 week turnaround? And the steps, this would include all the steps, right? Designing mold inserts, printing those inserts. There's a cleaning and post-processing step. There's no 3D printing process in the world that works quite like a 2D office printer where you can just come pick the parts up off the printer and use them. There is a post-process step. These components then all need to be fitted up into a mold frame that you're familiar with. We have some steps that best practices to share on that. And then we mold parts. And so we found very common to have all these steps completed in 4 to 7 days. We've done it over the weekend. So in as little time as 2.5 days. But typically that 4 to 7 day turnaround is a reasonable expectation. That's for folks who have the printer in-house, right? You do need access to the printer in order to get steps 1, 2, and 3 done in the first couple days. So the next slide really kind of sums up the presentation side, which is there's some important lessons learned. And that is that if you don't just buy a 3D printer, plug it in, and get all these advantages that I've spent a few minutes discussing here, you have to make a commitment to learn it. It's a new tool. But learning to use this new tool builds a real competitive and compelling business advantage. And we're not going to leave you alone. We have the steps in place. We'll show here the next thing. We've developed a best practices guide. That's a free download from the Fortify website. Again, lots of resources on our website. But that goes through every step of those processes, all 5 steps that we just showed. Best steps for design, best steps for printing, best steps for cleaning and post-processing the tools, and then for operation. That's free download. And then the next step beyond that, we talk about on the next slide, is Fortify's commitment to work with you step by step in our what we call our onboarding program. We go hand Hand in hand, side by side, we work with you through two complete projects. It's a low cost, low risk way to validate the claims we make in your shop or in ours. One of the other steps Fortify has taken is to actually have a printing press in our, or not printing press, but a molding press in our shop in downtown Boston. So we run projects, complete projects from design through parts in our shop in Boston. We can do runoffs of your mold in Boston. You can visit, even with COVID, we're hosting carefully some on-site visits. So those are the things I had to say. I'm anxious now to get to hear some of your questions and see what we can do to spread the word and spread the knowledge.
All right, awesome. Ben, great job. As he said, we are going to turn it over to you for some questions. As a reminder, to submit a question, you have multiple ways you can do that. You can email pnevents@crane.com. But if you're watching on Facebook or LinkedIn or YouTube, you can easily send those questions through those platforms. All right, Ben, here we go. Are there limitations to these types of tools? Can you make tools with side action, hand loads? Any thoughts on that?
Sure. If we would have had a little more time, we could have shown some of those. And again, if you go to the website, we have, I think, 3 case studies that demonstrate the use of hand loads. Again, the side action, we typically wouldn't take to the full automation side of side action, but hand loads, some very clever work going on with our applications engineering team. And I guess the key point is the accuracy of the printer to be able to print those hand loads with tight shutoffs. So the answer is yes. It can be used for those applications. We've had some pretty exciting success around that, and the information is available.
Okay, great. So here's a question that's come in from LinkedIn. Would the 3D printed mold insert, would its porosity affect the part quality if this insert would be implemented into production tooling?
So the porosity is not an issue. We're talking about polymer-based printing. So our parts have complete fully dense. That's porosity is more of a metal 3D printing thing than with polymer printing. Certainly with our technology. So porosity would not be the issue with implementing our tools in production. And, everybody's got their own definition of what production is. But when we talk about the high volume, hundreds of thousands of parts type arena, that would not be a fit for these tools. When we talk hundreds of parts, even low 1,000 part quantities, we have had success in that range. And that might make sense. But we're definitely careful to know, where we fit. We're not presenting this as a alternative for production tooling. That's, it's a different world. The cycle times and the emphasis is just different. This is a early stage solution to save a lot of time and a lot of money and a lot of heartache early on in the process.
Okay.
Or with low volume.
Yeah, right. So a question here, you did go over this, but it bears repeating. A question about cost and the timeline. So how much does it cost, and how much time does it take to make a particular part?
Sure. So in the size range we work, which would be typically 5-inch parts and below, almost any tool we make would be, if you own the machine and you're building parts, are going to be in about the $150 to $500 range to print the mold tools. And those tools would be good for, again, part quantity, anywhere from dozens of parts to hundreds of parts, or even a few thousand parts, depending on, polypropylenes are fairly easy materials to mold. As we move up into glass-filled nylons and things, lower part quantity. So that's how we would sort of calculate a total cost. If anybody has a specific project that they want to look at, we can very quickly rough out some numbers looking at a part. And if we do a complete analysis, can give, almost to the penny what the cost to produce molds and the cost to make parts from there.
Okay. Ben, you talked a little bit about training and onboarding. So the question that came in is, how long is that onboarding process?
Sure. So the onboarding process typically takes about best case, probably 4 weeks, and maybe 6 to 8 weeks on the far end. Because remember, there's a design, a part selection phase. There's a design phase we go through to help make sure we've got good design around draft angles, venting, gating. These are all things that, to the extent that we can be a little more generous with draft angles, gating, and venting on the parts, you get more shots. There's not a hard, fast rule of you must do this to get parts, but for sure, we make some when we make design accommodations, we get longer tool life. And that's a trade-off that's part of the onboarding program, is to sort of transfer that knowledge so that you can make calculations on your own. But that really comes to, we give you the tools to succeed. And again, we're dealing typically with pretty skilled engineering teams on our customer end. They take the tools we give them and they throw the limitations out the window and achieve amazing things. And again, I've seen that over the years. That's not just a Fortify thing. The people who take this application seriously, take the time to understand how to get the best advantage and best results, get amazing results. We just take it to the next level.
Right. I guess for me, it calls to mind a follow-up question. Does Fortify, or you personally, do you recommend a certain number of people at your customer get trained up? You don't want one point of failure if you're trained with one person.
No, it's a good point. I would say we typically will identify a lead, right? There's a champion. There's somebody in like, even when that knows more than anybody else about our process, and then they train the others. So we'll work with whoever, but maybe 1 or 2 or 3 people would typically be involved in the onboarding process. But we usually find that there's one engineer that really decides to make this their own and become the expert on it. And sometimes they have to overcome some friction inside the organization,
right?
And they want to prove, because it's new. It's a new idea in many cases. It's been tried, and maybe people have had not a good experience in the past with it. So that it really helps to have somebody at the customer side who is excited and pushes it forward.
Okay. Another question from LinkedIn. Could 3D printing be used for doing composites for high temperature applications such as fire barriers or even heat shields in aerospace?
So that would be, I think, more of a direct 3D printing application. So I'm going to assume that it is and spend a minute answering that. So the core Fortify technology about fiber reinforced or other types of additives, some of which might be fire retardants, applies in applications well beyond 3D printed tooling, right? This is one specific use case where we're using a ceramic fiber reinforcement to get those specific mechanical advantages in the materials. In other use cases, we would use different additives, different reinforcement, and different things like fire suppressants or smoke suppressants. And we are working on those applications. It's a whole universe of Q&A that could happen there that would be beyond this. I certainly welcome those kind of questions, but I think that's about as much of an answer as I could give in terms of staying focused on the molding application. We could mold parts that would have those properties.
Okay. Yeah, maybe perhaps that's more
the
genesis of the question. So again, just a reminder for our viewers out there, you can send your questions to pnevents@crane.com as it's scrolling by there. And if you're on Facebook, LinkedIn, or YouTube, send your questions through those platforms. All right, here's a Facebook question, Ben. Are you currently shipping these? Are these available today?
Yes, they are. Yep, machines started shipping this summer. It's not like we've been doing it for years, but the company is a 4-year-old company. The technology's been developing. We've been providing these molding as a service for 2+ years now. And machines have started rolling out into customer sites this summer, and it's pretty exciting, very exciting time actually in the in the life of a company. Not only are the machines going out, customers are getting them, they're using them, and molding parts. So it's exciting.
Yeah, for sure. All right, that's great. So, can we run glass-filled parts in these tools? Is the next question.
Yes, the answer is we have run glass-filled nylons, as we showed one of those case studies.
Right.
35% glass-filled nylon is the highest we've run. We would certainly be open to running higher fills. I think glass-filled polypropylene, and we're certainly open to any kind of material. We just look at the specifications, and it's a setting of expectations as the materials get more aggressive. We need to accommodate those.
Okay. And this, I'm going to read into this question a little bit. How can I try one of these machines in my shops? So maybe the question is, can we take these out for a test drive, kick the tires? Yeah. So the answer is yes. The first answer would be that we first try the output of the printers, and that's really the whole function of our onboarding program. We don't expect anybody to take our word for these claims. I think as we grow into the market and more of our customers are able to talk about the experiences they have with the tools, it gets easier. But for now, part of our onboarding process is we work with you, we print tools, we come to your shop, and we run them with you. So trying the output of the tools that's an easy yes. After you've done that, and we definitely have arrangements. Our business is to sell machines for sure. Yeah. And whatever practical methodologies we need to follow to engage with customers and give them a chance to try things, everybody puts skin in the game. And we do have machines available to run in the field. So okay, talk to me. Right. A question about end markets. Does the machine work better in certain markets, whether it be medical or packaging? What's your thoughts on that?
Sure. Well, we have found an interesting acceptance. I would say the medical community has embraced our technology for devices, not so much implantables and things like that, but medical devices. Those companies do a lot of innovation, in the smaller part sizes that fit our technology well. So I'd say we've had good acceptance there. I think we've seen good acceptance from OEMs, captive, what we call captive molders, right? Shops that are doing a lot of their own product development. And that's across industries, consumer products, medical products, heavy industry, you name it. If there's plastic parts and innovation going on, that works. And then I think we see a lot of interest from custom molders who want to be involved early in the process, right? Some custom molders are focused on volume manufacturing only, and that's not really a fit for what we do. But the custom molders who say, hey, if I want to get that volume business, I need to engage earlier and strategically see that as a fit for their business. We have great engagement with them. But it's really more with molders who are doing a lot of innovation, whether they're captive or custom molders, and regardless of the industries that they're in.
Okay. Now, Ben, you've been in this the 3D printing game for 15 years or more, 16, you said, coming up. Yeah. And 3D printing has been talked about for a long time. Is it, in your opinion, is it mainstream now? What's the uptake in 3D printing?
Sure. So I would say 3D printing is absolutely become a mainstream technology. Now, don't get me started on 3D printing versus additive manufacturing, right? Because that could go on for another half an hour. But I think that 3D printing, prototyping, the use case like we're talking about here, tooling, jigs, fixtures, things that make a manufacturing operations more efficient, I think I'm not, whatever mainstream means, it's certainly very widely used. I think the next frontier of true additive manufacturing, where people are using this tech source for their product, is the next wave. And I think that's certainly starting in pockets. I would not say additive manufacturing has become mainstream. The conversations have become mainstream, and that's where things start. But for sure, that's part of Fortify's strategy, is to start with what I would consider a 3D printing application, these mold tools, and transition with the interest we get into volume direct additive manufacturing applications.
Okay. Well, wonderful. Well, to all our viewers out there, thank you so much for the questions. Ben, any parting words of wisdom for everyone out there watching?
Boy, if you're watching, like, my words of wisdom be, if you have enough time, energy, and interest to join us here on this today, and you don't have some kind of 3D printing going on in your operation, your organization today, any kind of jigs, fixtures, tooling, get started. Because it's really an application space that feeds on creativity, and it's just, you can't create without the tools. And it's very, very inexpensive to get started with 3D printing. So that's my platform, and my message has been for years. And again, I've seen many, many, many companies over the stretch of my career in 3D printing go from nothing to being on the cusp of huge additive manufacturing breakthroughs. And so you got to be in the game to win. So that's my advice.
That's right. That's well said. Well, Ben, thanks so much for sharing your insights today. To those of you watching, if you want to reach out to Ben, email him at the address on the screen. I know he'd be happy to speak with you. He said as much. So my thanks to our expert, Ben Arnold of Fortify. My thanks to you for joining us today for Ask the Expert. Check out our entire 6-part series on improving operations by visiting plasticsnews.com/ask-expert. Until then, have a great day. I'm Brendan Lafferty. Thank you for watching Ask the Expert with Plastics News. And don't go anywhere. Stay tuned for a parting message from Fortify.